The last part of this lesson talks about special right triangles, and everybody loves a shortcut. The Pythagorean theorem is great, but you have to know 2 of the 3 sides, and sometimes you just don't have all that information. So if the triangle is one of our 2 special triangles, you only need 1 of the 2 sides in order to find all of them. So our first special triangle is a 45-45-90 triangle. If you look at this picture, 45-degree angles, and if you remember about triangles, if the base angles are equal, the sides are equal. Every 45-45-90 is an isosceles triangle. That's a nice tip. In words, 45-45-90 triangles. The measure of the hypotenuse is the square root of 2 times the measure of a leg. Well, is means equal, but that's still a lot of words. And so what this really means in a formula version is the hypotenuse is the leg times the square root of 2. If you know the hypotenuse or you know the leg, you substitute it into the equation and you solve for what you don't know. And clearly our legs here are both going to be the same and our hypotenuse is out there. Now 30, 60, 90 triangles have a 30-degree angle, a 60-degree angle, and that 90-degree angle. 2 formulas in this case. Sorry about that. The 60-degree angle is opposite the long leg. Big angle, big side. Short side is opposite the 30-degree angle, and the hypotenuse is always where the hypotenuse is, opposite the 90. And so what we know is that the hypotenuse is equal to 2 times the short leg, and the long leg is equal to the short leg times the square root of 3. So if you know one piece, you can substitute it into these 2 equations, and you can solve for what you don't know. Again, it's maybe going to require dividing by a radical, multiplying by a radical, but we've been practicing that. So let's look at some examples. So first, you always have to determine what kind of a triangle you have. So in this first example, these hash marks tell me I have an isosceles triangle, which tells me I have a 45-45-90 triangle. I'm missing the hypotenuse. So the formula is the hypotenuse is the leg times the square root of 2. I know the leg, so I substitute in. The hypotenuse is 3 square roots of 2. And you're done. Now here, I have a 30, 60, 90. Here's my hypotenuse. If this is my 30, that makes this my short side, and this is my long side. Now I want the long side. The formula said the long side is the short side times the square root of 3. Short side is 8. Substitute that in. The long side is 8 square roots of 3. I have another 45-45-90 because I have another isosceles triangle. I know the hypotenuse. Hypotenuse is the leg times the square root of 2. So this time I'm subbing in over here because I know the hypotenuse. So I have 4 square roots of 2 equal the long leg times the square root of 2. And remember, these are the legs, they're the same. Divide by the square root of 2. Those cancel, and the leg is 4. D is a 45-45-90. If there's your equal side, so that means this side is 15. That means this side is the hypotenuse. Formula says the hypotenuse is the leg times the square root of 2. So the hypotenuse is 15 square roots of 2. And it really is as easy as writing down the formula and substituting in what you know. In this case, here's 30. So I'm given the short side. Here's my hypotenuse. This is the hypotenuse. This is the 60 here. So that makes this the long leg. So the long leg is the short side times the square root of 3. I know the short side, so my long side is 5 square roots of 3. My hypotenuse is 2 times the short side, so my hypotenuse is 2 times 5. My hypotenuse is 10. Here, 30, 60, 90, I know the long side. Here's my hypotenuse. This makes that my short side. So my long side is equal to my short side times the square root of 3. So I have 14 square roots of 3 equal to my short side times the square root of 3. Divide by the square root of 3. Cancels. The short side is 14. Once I know the short side, I can find the hypotenuse is 2 times the short side, so my hypotenuse is 28. Every one of these will check if you go back and apply the Pythagorean theorem. So, can our problems get more complicated? Not really. My pictures, yes, but the problems, no. It's all about getting your bearings, knowing what kind of triangle, what are your short sides, your long sides, your legs, your hypotenuse. So in this case, we're going to focus on one triangle here, and I want the length of AC. I'll call that B, right here. So what is that in relation to what I know? So again, I have an isosceles, actually I have an equilateral triangle, but when I look at this, perpendicular bisector theorem, these are the same. So this bottom, B to C, is 4. If this is 60, that makes this my long side. That makes this 30. That makes this my short side. And so I know that the long side is the short side times the square root of 3. Substitute in what I know. The long side is 4 square roots of 3. So pulling back some old knowledge from quarter 1 and drop it into a new formula. So what about a ladder problem? Can we solve those as special right triangles? So we've got our building underground. We've got our ladder leaning against it, and we're assuming our building is square with the ground. The ladder makes an angle of 60 degrees with the ground. So that's one of our difficult spots. So the ladder and the ground make a 60. If you get that in the right spot, you're good. How far up the wall does the ladder reach? So we want this height here. And we've got a 6-meter long ladder. Our ladder is 6 meters long. So what do we know? We know the hypotenuse. We want the long leg. Fortunately, there's no way to get from hypotenuse to long leg without going through short leg. So hypotenuse is 2 times the short leg. My short leg is 3. We take that because we know our long leg is the short leg times the square root of 3. So that gets substituted in. Our long leg is 3 square roots of 3, which is approximately, because we don't measure things in square roots, is approximately 5.2 meters, even though exact answers are always best. Now for my sports fan, one last example, actually 2, baseball diamonds. So let's work A first. We've got a baseball diamond, which is really a square, not a diamond. Here's home plate. Baseball diamonds, 90, and we know we have a right angle at each place. So the nearest foot, how far is a throw from second base to home, or from home to second? Would our catchers be throwing? Well, since we know that it's a square, we know that this is 90. Since those are the same, and if we remember about squares and the diagonals from quarter 1, we know that this bisects the angle, so we know we have a 45, 45, 90 triangle. We are interested in this length here from home to second base, which happens to be the hypotenuse of a 45, 45, 90 triangle. And so if we remember, our hypotenuse is our leg times the square root of 2. Our legs in this case are 90. So our hypotenuse is 90 square roots of 2. Again, a beautiful exact answer, but no one is going to know how far it is if you say it's 90 square roots of 2 feet. So when you multiply that out, you get approximately 127.3 feet. Pretty nice throw for those catchers. If we look at example B here, we start with another baseball diamond, home plate, square angles there. What's the length of a throw from the shortstop position to first base if the shortstop is midway between second and third base? So our shortstop is exactly halfway. And how far is that super common throw there? Well, I know this is 90, and if this is the midpoint, I know this is 45. Now, as tempting as it might be, we don't know anything about this angle. And so our special right triangles don't work. But what does work in this situation with every right triangle we ever meet is the Pythagorean theorem. And what we're looking for in that throw is the hypotenuse of this triangle on the side. And so we are looking at h squared is equal to 45 squared plus 90 squared. And so h will end up being 100.6 feet. Also a very nice throw. That is it for this lesson. Good luck on your homework.